In this video, we're going to discuss the 2010 CSSA Extension 2 Question 7c, which is a question on inequalities. So to begin with, it says, show that if a and b are both greater than 0, then a over b plus b over a is greater than or equals to 2. Now, every single question must start with the statement that when you subtract two real numbers and you square them, the result has to be greater than or equals to 0. That's just a basic property of squared real numbers. Any of these two numbers. So we could rewrite that as saying square root of, this is any number, this is any other number, their difference, squared, has to be greater than or equals to 0. But the reason I wrote it like that is because that gives us the conclusion that if we expanded this perfect square, we have this inequality. Now this is commonly known as the AMGM, which means the arithmetic mean is greater than or equals to the geometric mean if the 2 was on the denominator here, right? Arithmetic mean, x plus y on 2, geometric mean, product, square root. Now all you have to do is just realize the correct substitution. So here x should be a on b, y should be b on a. Their sum, which is our left-hand side, is greater than or equals to, according to the AMGM, of this, which simplifies to 2. Notice how the way I've written things is, I've written that this is greater than or equals to this, which is equals to 2. So I always write this in descending order. You cannot go, oh, this is greater than or equals to that, which is then later equals to something else, which is then smaller than something else, and then say that A is well, what is it then? Is A is greater than or equals to C, or is A is less than C? We don't know. You see, your working out would never want to look like that. You want to always go in descending order, and we have gone in descending order, so therefore our conclusion is that the left-hand side here is greater than or equals to 2. So that's the notation that I'm in the habit of writing. Now the second part says to show that if these two numbers are positive, then this is also greater than or equals to 4. Now this is obviously just a case of examining the left-hand side a little bit more closely, expanding it all out, that's an A, simplifying it, realizing that these two are just 1s adding up to 2. But we know that that from part 1 was greater than or equals to 2. So if something is greater than or equals to 2, then 2 plus that is really greater than or equals to 2 plus 2, right? So this part and that part was drawn from part 1 of the question, okay, and overall equals to 4. Again, using descending order, the left-hand side is therefore greater than or equals to the right-hand side, 4. Now in part 3, they said hence or otherwise. Now I'm not sure what they mean by hence. Maybe they said hence just because it's this in the spirit of the work that we've done so far. And frankly, expanding the left-hand side is not very hard because that's 1, that's 1, and that's 1. So that gives us 3 already. Now over here we've got A on B, A on C, and B on A, and all this mix of other stuff. Fortunately, the statement that you proved in part 1 of the question can be rewritten for any two letters, such as A on C, C on A, B on C, and C on B. And all of them are greater than 2 because there is no restrictions on these numbers. Okay, so we're just rewriting the equations. And as you can see, by doing that, we can now say A on B, B on A, cool, A on C, C on A, and B on C, and C on B. So all of these things end up telling us that this whole expansion is now greater than or equals to 3 plus 2 plus 2 plus 2, which is equals to 9. So according to our descending structure, you can now say that the left-hand side, which is A plus B plus C, is greater than or equals to 9. This is by no means difficult. The technique of revolving your numbers around the same structure but cycling through using all the combinations of the 3 letters is very common in the course, but by no means not the only way of doing these questions. In this situation though, it is probably the easiest way.